Children, it is a continuation of the chapter motion. Now let us discuss about the rate of change of velocity, that is nothing but acceleration. When a object is moving along a straight line path with uniform speed, the velocity will not change. The velocity remains constant with time. In this case, the change of velocity is 0. The change in velocity of the object for any interval is 0. But in non-uniform motion, velocity changes with time. So it has different values of velocity at different instants, and at different points of the path the velocity is different here. Thus there is a change in velocity of the object when it is moving along a straight line path with non-uniform motion. The change in velocity of the object during any time interval is not 0 here. To express the change in velocity of an object, we are using the word acceleration, that is one of the physical quantity. Acceleration is one of the physical quantity which measures the change in velocity of an object per unit time. So what is acceleration? Change in velocity of an object per unit time is called acceleration. Acceleration is the rate of change of velocity. It is the change in velocity of an object per unit time. So acceleration is equals to change in velocity by time taken. Change in velocity by time taken. If a body starts with velocity u, that is the initial velocity, and after time t, its velocity becomes v, that is the final velocity. Here the initial velocity of the object is u, and the final velocity, that is after the time t, is v. Then acceleration is equals to v minus u by t, and you can denote the acceleration by the letter a. So you can write a is equals to v minus u by t. A is equals to v minus u by t. Here u is the initial velocity and v is the final velocity, t is the time taken. This type of motion is called accelerated motion, as acceleration is rate of change of velocity and velocity is a vector quantity, therefore acceleration is also vector quantity. SI unit of velocity is ms to the power of minus 1, that is meter per second, and SI unit of acceleration is ms to the power of minus 2, ms to the power of minus 2, that is meter per second square. It is the SI unit of acceleration, and here the acceleration means it is change in velocity. Change in velocity means increase in velocity or decrease in velocity. Therefore, here increase in velocity means the acceleration is positive, decrease in velocity means the acceleration is negative. So what is positive acceleration? If the velocity of an object increases with time in the direction of motion, then the acceleration of the object is said to be positive acceleration. If the velocity of an object increases with time in the direction of the motion, then the acceleration is said to be positive acceleration. That is the increase of velocity in the direction of the motion. And what is negative acceleration? If the velocity of an object decreases with time, then the acceleration of the object is said to be negative acceleration. And the other term or other name of the negative acceleration is retardation. That is nothing but decrease in the velocity. And you know that the acceleration may be uniform acceleration and also it may be non-uniform acceleration. Non-uniform acceleration. So what is uniform acceleration? If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform acceleration. So what is uniform acceleration? If the object travels in straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform acceleration. Uniform acceleration. Motion of freely falling body is an example of uniform acceleration. In this case, the body is falling under the influence of gravity and its acceleration is uniform acceleration because the velocity goes on increases with the equal amount in equal intervals of time. Therefore, the motion of freely falling body is under the uniform acceleration. And non-uniform acceleration. When the object travels in a straight line, if its velocity changes in unequal amounts in equal intervals of time, then the acceleration of the object is said to be non-uniform acceleration. What is non-uniform acceleration? When the object travels in a straight line, if its velocity changes in unequal amounts, in equal intervals of time, then the acceleration is said to be non-uniform acceleration. Example is, so you take the movement of any vehicle. So if a bus traveling along a straight road, it changes its velocity by unequal amounts in equal intervals of time, then the bus is said to be moving with non-uniform acceleration. Non-uniform acceleration. So this is the example for the non-uniform acceleration. Here there is a problems based on the acceleration. So let us take the first one. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 ms to the power of -1 in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second, that is 4 ms to the power of -1 in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. First case, here the bicycle is at stationary position. Rahul starts it by paddling and his bicycle reaches a velocity of 6 ms to the power of -1 in 30 seconds. So let us consider this is the case first. So here in the first case, let us take here starting position. It was at stationary. Means the initial velocity, that is u is equals to 0. What is u here? That is initial velocity. U is equals to 0. Next, its velocity reaches 6 meter per second. So let us consider that is v. V is equals to here 6 ms to the power of -1. What is the time taken to reach that velocity? That is t is 30 seconds. Time taken to reach 6 meter per second is 30 seconds. Here the cycle was at rest and it reaches the velocity of 6 meter per second after 30 seconds. Here the question is, what is the acceleration? So you write A is equals to question mark. A means here acceleration. A means acceleration. So you write the formula for the acceleration, that is A is equals to V minus U by T. What is V here? That is the final velocity and U is the initial velocity and T is the time taken to reach that final velocity, and you substitute the values here. That is A is equals to V is 6 ms to the power of -1 and U is initial velocity, that is 0 ms to the power of -1 ms to the power of -1 by Time taken is 30 seconds. Here it becomes A. 6 minus 0 is 6 only. That is 6 ms to the power of minus 1 by 30 second it is. Then it becomes A is equals to, know that here 6 divided by 30, that is 6 divided by 30, you put 0 here, so it becomes 0.32 is 60, so you will get 0.2 m s to the power of minus 1 by s. So it is nothing but A is equals to 0.2 ms to the power of minus 1. This s is in the denominator, means it is also s to the power of minus 1. So it becomes A is equals to 0.2 ms to the power of minus 1 plus minus 1 is minus 2. That is 0.2 ms to the power of minus 2 is the velocity, that is the acceleration when the initial velocity is 0 and the final velocity is 6 ms to the power of minus 1. And the second case here, what is the second case? Second case, that is here after reaching the velocity, see the question, after reaching the velocity 6 meter per second, he applies brakes such that the velocity of the bicycle comes down to 4 ms to the power of minus 1. 4 ms to the power of minus 1. So here you consider 6 ms to the power of minus 1 is the initial velocity, 4 ms to the power of minus 1 is the final velocity, and the time is 5 seconds. So right, in the second case, u is equals to 6 ms to the power of minus 1, v is equals to 4 ms to the power of minus 1. Time taken is here, that is 5 seconds. 5 seconds, that is the second case. Here it is second case. Now again you write the same formula for A, that is A is equals to v minus u by t. That is equals to v is here 4 ms to the power of minus 1 minus 6 ms to the power of minus 1 v minus u by t. T is 5 seconds. 4 minus 6 is minus 2 ms to the power of minus 1 by 5 seconds, and here you divide 2 by 5, that is 2 divided by 5. So here you put 0, that is 0.5 20. So you will get is equals to minus 0.4 ms to the power of minus 1 by s, that is equals to minus 0.4 ms to the power of minus 2. Here that is retardation, negative acceleration. In the first case it is positive acceleration because here the velocity increases, and in the second case the velocity decreases. One more question, that is a bus decreases its speed from 80 km per hour to 60 km per hour, that is 80 km h to the power of minus 1 to 60 km h to the power of minus 1. In 5 seconds, find the acceleration of the bus, and it is known that here the speed decreases, so it is negative acceleration. So let us consider the initial velocity u is equals to 80 km per hour km h to the power of minus 1, and v is equals to 60 km per hour, and time is 5 seconds. Time is 5 seconds. Next here you write the formula for A, that is A is equals to v minus u by t, that is equals to V is here 60 kilometer per hour minus U is 80 kilometer per hour by how many seconds? Within 5 seconds. Now 60 minus 80 is, that is minus 20 km h to the power of minus 1 by 5 seconds. Here it is kilometer per hour. So you convert this into meter per second. So it becomes minus 20 kilometer means minus 20 into 1000 meter by 1 hour. Per hour means per 1 hour. Into here it is 5 seconds. Next here it becomes minus, can convert that into 5 ones are 5 minus 4 it is. So it becomes minus 4 into 1000 by 1 hour means, that is S is already is there, 1s into 1 hour means 60 into 60 seconds it is. Here it is meter, 60 into 60 seconds, that is equals to, here you know that 0 0 cancels, 0 0 cancels, and here it becomes minus 40. Minus 4 into 10 is minus 40 by 1660. 6 into 6 is 36. S into S is S square it is. Then it becomes, you know that 4 tens are minus 10s are and 4 9s are. So you will get minus 10 by 9 S square. You can divide the 10 by 9. It becomes 9 ones are 9. You will get 1 here. Again you put 0. That becomes point. So it becomes minus 1.1. Here it is meter. ms to the power of minus 2. ms to the power of minus 2. Minus 1.1 meter per second square it is. That is the acceleration of the bus. That is negative acceleration here. As the speed decreases, the acceleration is negative acceleration. So you write A is equals to minus 1.1 ms to the power of minus 2. See, again there is one question. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So here the train starts from the railway station means its initial velocity is 0 here. And it reaches a speed of 40 km per hour means, that is V is equals to 40 km per hour. And the time is 10 minutes. So here write the time, T is equals to 10 minutes. Then you can convert the V in terms of meter per second, that is 40 into 1000 meter per hour. So it becomes 40 into 1000 meter per hour means, that is again 60 into 60. 60 minutes means 1 hour. Again 60 seconds means 1 minute. So it becomes 60 into 60 seconds. And it becomes 0 0 cancels, 0 0 cancels. Then it is 400 by 6 6 36 meter per second here. Then you know that if it is possible, try to cancel 4 9s are 4 hundreds it is. Then you will get 100 by 9 meter per second here. And here T is equals to 10 minutes. Again you convert that into seconds. So t is equals to 10 minutes, that is 60 into 10. You convert this into seconds, then it is 60 into 10 seconds. So it is 600 seconds. 600 seconds. Then you write the formula for A. That is A is equals to V minus U by T, and that is equals to V is here 100 by 9. 100 by 9 ms to the power of minus 1, that divided by t is 600. Yes. So it becomes A is equals to 100 by 9 into 600, that is ms to the power of minus 1. Here it is yes. Then you know that 100 ones are 100 6 are, that is 1 ms to the power of minus 1 by 9 6 are 54 second, that is equals to A is equals to 1 by 54 ms to the power of minus 2, that is acceleration is 1 by 54 ms to the power of minus 2. That is the acceleration of the train when it starts from a railway station.